Now let's take a look at subnetting operations. These are my 8 subnetting tasks. We'll call them Raleigh-Jones subnetting tasks, RJ subnetting tasks. I just like to use these in my classes because they give me a way of keeping track the items that I will need to do in understanding subnetting. These could also be called subnetting rules. The first 3 items on this list, default mask, network bits, and host bits, all of these can be derived from knowing one piece of information in an IP address. That piece of information is the class of the address. You'll recall that there are 3 classes of addresses that we want to be concerned with in our networking and in our subnetting. Class A, Class B, and Class C. Each one of those classes has a unique default mask. Class A has an 8-bit default mask, Class B has a 16-bit default mask, and Class C has the 24-bit default mask. That default mask indicates which portion of the address is going to be network bits and which portion of the corresponding address will be the host bits. So all 3 of these pieces of information can be derived simply knowing one thing, the class of the address. Now, just for fun, let me give you an example of that real quick, just to clarify something that often my students come into the class, misunderstanding that a lot of students have coming into class. If you see this address right here, 10.1.1.1, with an IP address of 255.255.255.0, oftentimes students will come into the class and I'll ask them, what class address is this? They'll say, oh, it's a Class A. They'll look and see it's a Class A address. But I'll say, what class mask is this with this address? And they'll say, well, that's a Class C mask with a Class A address. And that's actually not correct. This is a Class A address with a 24-bit mask. The mask itself does not have a class. The class defines or determines the mask. So this is actually a Class A mask, if we were going to refer to that from the default, with 16 additional bits of subnetting. So this is not a Class C address because of this mask, nor is it a Class A address with a Class C mask. This is simply a Class A mask with a 24-bit mask. You could also view it as a Class A address with 16 bits of subnetting being done because there's 8 by default and then there are an additional 16 here that are used in this particular mask. So now that we've made that clarification, let's go on further with our tasks. As we mentioned, the default mask, network bits, and host bits can all be derived simply knowing the class of the address. That first octet determines the class. The fourth task or rule that we want to look at is the subnet mask. We'll find our subnet mask based on a very technical term. You want to make sure you write it down correctly and spell it correctly. Very technical term, and that term is, be careful, don't spell it incorrectly. That term is needs. Now I say that sort of tongue-in-cheek because a lot of times people want to make the subnet mask or the subnetting concepts, want to make them a lot deeper than they are. The reality is the reason why we come up with a subnet mask is based on the needs of the given situation. Or another way of referring to these needs would be customer requirements. If you're going in to design a network and the customer has requested a particular number of subnets and a particular number of hosts per subnet, those are your needs. Another way of viewing those customer requirements or those needs would be the customer tells you, well, we want 20 departments and each one of those departments would have 50 computers in each department. Those are customer requirements or those are needs. And therefore you would take whatever given address that you might have by default, whatever given address that you're working with, and then you come up with a subnet mask based on those customer requirements or customer requests, the needs. Now, the fifth rule here And by the way, we'll take a look more specifically at each one of these, particularly this subnet mask, when we get into our examples. The fifth rule here is the subnet address. Notice the subnet mask and the subnet address are two entirely different things. Oftentimes in my classes, students will refer to the subnet mask as the subnet. They say, well, what's the subnet? You know, there's an IP address and then there's the subnet. No, the reality is the subnet mask is different from the subnet. The subnet is synonymous with the subnet address, and sometimes this is also referred to as the subnet number. So subnet, subnet address, subnet number, all the same thing, whereas the subnet mask is a totally different item. The subnet mask is based on needs. It's used to differentiate between the subnet portion of an address and the host portion of an address. And we'll look specifically at some examples on that. But the subnet address itself is derived by using a little rule that we'll be using in our examples. The subnet address is all host bits set to 0. We'll follow this rule in order to determine what the subnet address is or the subnet number is for any given scenario or situation. And then the next rule, the first host address, the first valid host address will be the subnet address plus 1. That's the rule on gaining or finding the first host address. And then there's the broadcast address. The broadcast address, and I'll just give us a little bit more space here. The broadcast address, the rule here is set all host bits set to 1. So set all host bits to 1 for the broadcast address to find the broadcast address, and set all host bits to 0 to find the subnet address. There's exact opposites there, and we'll see how those work. And then the last host address would be the broadcast minus 1. Broadcast minus 1. So notice the first host was the subnet plus 1. The last host is the broadcast minus 1, the broadcast address minus 1. These two items combined, 6 and 7, these two items give us the valid host range of addresses. So you may see those referred to as the range. So you might be asked in a particular situation to give the subnet address, the broadcast address, and the valid host address range. That's what they're talking about. The first host address and the last host address would make up the range.